In this video, we'll learn how to use the computer simulation applet to find the percent of simulated statistics that are higher than our observed statistic or lower than our observed statistic. So here's the example. I roll a die 60 times, a fair die. I get 14 fives when I roll it those 60 times. So first it says, Part A, use the computer simulation applet to create a distribution of 100 simulated sample statistics. So again, we go to the Rossmann-Champs applets. We go to the one proportion inference, and we hide the coins in the top right corner. Remember, up in the probability of heads box, you always put the value of the population proportion pi. Since we said that this is a fair coin, the population proportion would be 1/6, which is approximately 0.167. It would roll fives 1/6 of the time in the long run. So pi is 1/6, or approximately 0.167. It told us that in our sample, we are rolling the die 60 times in a row. So our sample size is 60 in the second box. And it asked us to create a simulated distribution of 100 sample statistics, meaning we want 100 dots in our distribution, 100 sample statistics. So I make the number of samples 100, and I click Draw Samples. I am currently sitting on number of successes, and here's the distribution I got. I'm going to go ahead and make a copy and paste of that into my document. There we go. I'm going to go back to the applet and recall that you can also click the proportion of successes box, and it gives you the same distribution, of course. It just labels the horizontal axis with the equivalent proportion of successes for each of those sample statistics. I'm going to go ahead and copy and paste that into my document. Okay, so we've now created our simulated distribution of sample statistics. This, remember, tells us that if we have a fair die that we rolled 60 times, these are the sort of sample statistics we can expect. Part B asks, what is my sample statistic? So in the beginning of this problem, it said, I roll my die 60 times and I get 14 fives out of 60 rolls. So that tells me my sample statistic is p hat equals 14 successes out of 60 total rolls. If you divide that out, you get about 0.233, which is 23.3% of, which means when I rolled this fair die 60 times, it rolled a 5 23.3% of the rolls. Part C says, use the simulated distribution of sample statistics to identify the probability of getting a sample statistic like mine or higher. So my sample statistic was 14 fives out of 60. 14 out of 60. So if we look at the first distribution, we're talking about right here. So this would be 13. Here's 14. So we're asking how many of these simulated sample statistics were like my p hat equals 14 out of 60 or higher. So it would be all the dots like 14 and higher out of 100 total dots. So what I see here is I count 6 total sample statistics in the simulated distribution. So 6 dots that are like mine or higher out of 100 total dots. So the probability of getting a sample statistic like mine or higher is 6 out of 100, which is 0.06 or 6%. Now notice, if you ran the simulation on your own computer, or even if I ran the simulation a second time, we would get a different distribution of sample statistics. Every time you run that simulator, you get a slightly different set of dots. So you might have a probability here that's a little different, but I highly suspect it's nothing like 90%. I suspect it's less than 10%. So it should be similar to what my probability is here. Part D says, my friend rolled a fair die 60 times and got 4 5s in the 60 rolls. And again, asked to use the simulated distribution of sample statistics to identify the probability of getting a sample statistic like my friend's or lower. So if my friend got 4 out of 60, so we would be talking about right here. Here is 4 5s out of 60 rolls. So how many are like that or lower? There are 3. So 3 dots like my friends or lower out of 100 total dots. That means the probability is 0.03, or 3% chance that one of these simulated statistics is like my friends or lower. Again, yours might be a little different because your distribution would be a little different. I want to now show you that you can actually have the computer applet do these probabilities for you. My sample statistic, remember, was 14 out of 60. So if I go into the applet and you see this area down here at the as extreme as row, you put your sample statistic here, first making sure that you're entering a value that corresponds with either number of successes or proportion of successes accordingly. If I want to put in 14 to represent 14 successes out of 60, I need to be on number of successes. If I choose instead to put in the proportion 0.233, then I would switch to proportion, and you see you need to put that in that way. Back to number of successes, you need to enter 14. At proportion of successes, you need to enter 0.233. I then tell the computer, I want you to count the dots. I want you to count the sample statistics that are greater than or equal to 14, the dots that are like mine or higher. And you see it puts this vertical red bar there. It says the dots that are greater than or equal to 14, and it counts them. It turns them red. It says there are 6 dots out of 100. That's down here under proportion of samples. 6 out of 100, so 0.06. 6% of them are like my statistic or more extreme. Recall that my friend got 4 out of 60, so 4 successes out of 60. So if I want to change this to 4 successes out of 60, and I was counting how many are like 4 or lower, so I need to switch this little inequality symbol to make sure it's counting 4 or lower. You see the vertical line is added, and it turns the dots red that are 4 or lower. There's 3 dots like that. And it says the proportion of samples that are like my friends or lower is 0.03, 3% of them.